Hi students, how are you today? Welcome to our lesson. Today we're going to be doing our do now, which is kind of fun. We're going to complete a positivity chart. Our objective will be to classify, add, and subtract polynomials because we are starting a new unit today. So our essential questions are, what is a polynomial? What is the standard form of a polynomial? What is the classification and degree of a polynomial? And how do I add and subtract polynomials? So for your assignment for class today, you'll complete the do now, the 2 pages, and the exit ticket. And if you are a distance learner, submit your work on Teams. And if you're in class with me, you can just show your work to me in person. For homework, we have homework 1, classifying, adding, and subtracting polynomials. And look for the Unit 7 calendar. It's actually finished, and you should find it labeled as Unit 7 calendar in the same place that you found this assignment. So we'll come back to the exit ticket in a few minutes, but for now, just to keep our heads screwed on, pretty positive, we have a positivity chart. I love charts. I make charts for so many things. It's good to have an ordered mind, and that helps with math especially. So I'd like you to write something that went well this week, something that you're good at doing, and something that you're thankful for. And I'll share that I am certainly thankful for my students. So thankful for you. So let's get to our lesson. Okay, new unit, polynomials and factoring. Students, I encourage you to really focus on this unit to the extent you really focus on especially the factoring portion of this. You will be well served when we move into those quadratic equations next. So a polynomial is an expression of many terms. Now, I always consider it 4 or more terms because I like to use the term binomial and trinomial, but I've seen people use it for 3 terms. They've considered 1 term a polynomial that's called a monomial. You know, I've seen all kinds of things, but it is basically poly means many, okay? So examples would be 6x squared plus 2y plus 3, or you could have 9x to the third plus 4x squared minus x minus 2. So those are all polynomials, but the standard form of a polynomial must be written in alphabetical order with the highest exponent first, and then those exponents will decrease just like here in my example. So we want to write our polynomials with in alphabetical order. And let's just say in decreasing order of exponents. And that's from left to right. So we're asked to write each polynomial in standard form. So all we're doing here is reordering. So I have a square term and a 1 degree term, and I have that constant. We always put the constants last. So this is 2x squared plus 3x. Remember, we have an invisible positive sign in front of anything without a sign, plus 1. So try 2, 3, 4, 5, and 6, and let's see how you do. So for number 2, I would start out with a positive 7k to the third power, and you can omit the positive sign. That can become an invisible positive sign, plus k to the second power, minus k plus 64. For number 3, I would start with w to the third power, plus 5w to the second power, minus w plus 28. We always put the constant last. Number 4, we'd start out with negative n to the third power plus n plus 24. We have an invisible positive sign right there. Okay, number 5, we'll start out with we have an a to the third power and we have a b to the third power. We do AB order, so it would be a to the third, then we would do this plus 5a to the second, b to the second. Okay, so we've got this. Then we would do the 2ab, because it has an a in it, so that's plus 2ab minus 2b to the third. So alphabetical order is first, then descending order of the exponents. And number 6, I would start out with negative c to the third power, and then minus 7c squared d squared, and then my 5d to the third power, and then the constant plus 13. Okay, now we also just note that the degree is exponents are classified by their degree and the number of terms, okay? So let's look at classifying these polynomials. So we have polynomials. We can have a degree of the polynomial, and we can have a number of terms in the polynomial. So if the polynomial has just a constant, no variables, okay? Okay, and it's one term, then it's a monomial. A linear equation is going to have a degree of 1. A quadratic equation would have a degree of 2. A cubic equation would have a degree of 3, and a degree of 4 would be considered a quartic equation. Now, the number of terms, if there's one term, it's a monomial, 2 terms, binomial. Okay, so bi meaning 2, mono meaning 1. 3 terms, trinomial. And I think you know these prefixes pretty well, probably. And then 4 or more, we call that a polynomial. So now we're going to classify some of these. So let's look at 7, 8, 9, 10, 11, 12. So we have simply the number 6. That is a constant, so we're going to classify it by degree and number of terms. So that is a constant monomial. Okay, the second one, number 8, that is a linear, okay, is a degree of 1, linear expression, and that is also a monomial. Now, 7p plus 1 has 2 terms. It's a binomial, but when we look at the degree of the exponent, it is still linear. Its graph makes a straight line. And when we look at number 10, we've got a square. It's got a degree of 2, so it's a quadratic. And with 3 terms, it is a trinomial. And we'll be doing a lot with these for the rest of the year. And number 11 two terms is a binomial, but a degree of 3 makes it a cubic. So it's a cubic binomial. And with 4 terms, the last one, number 12, is a polynomial, and it has the highest degree of 4, so that's a quartic polynomial. Okay, so now let's think about adding and subtracting. We're going to add and subtract polynomials. Well, all we're going to do is combine like terms. You've been doing this in 7th grade. So let's think about this. Let's start with the addition example. We're going to start with our square, our highest degree. So we have x squared plus 2x squared. But we have a negative 1. This is a negative invisible 1. I'm going to change my colors as I work. So I'm going to make the line a little thinner. And I'm going to change my colors. Okay, so we have negative 1x squared plus 2x squared. So 2 minus 1 is 1x squared. So that's x squared. Now, we have 11x minus 5x, which is positive 6x. And I'll change the color one more time. We have 13 minus 23, which is negative 10. And that's our final answer. So let's look at the second one, the subtraction example. We have 4x minus 3x squared. So that's x squared. And then we have 5x minus 7x, that's negative 2x. And then all we have is this plus 1, but we're subtracting it, so it's minus 1. Okay, so let's move on to some of these. Number 13 through, 13 through 24, and then we have little more complicated ones at the end. So x plus 5 plus 4x minus 7. So x plus 4x, that's 5x. 5 minus 7 is negative 2. So k squared minus 4k plus 7 plus k squared plus 9k minus 3. That's 1 and 1 make 2k squared minus 4 plus 9, so that's plus 5k, plus 7 minus 3 is plus 4. Change the color again. Okay, w to the third minus 2w squared minus 5 plus 3w to the second minus 11. So there is only one w to the third term. And then we have negative 2 plus 3 equals 1, so it's plus w squared. Negative 5 minus 11 is minus 16. So in next one, number 16, we do not have a constant, so it'll be minus 7 at the end. We have 9 plus 3, that's 12x. Then we have negative 5 plus 2, so that will be negative 3 on the y minus 7. Number 17, we'll start with the p squared. Negative 1 plus 1, the p squared goes away. We don't write it. You don't write 0p squared. It just is eliminated. Then we have 5p minus 4p, so that's just p. 8 minus 15 is negative 7, and that's our final answer. Number 18, let's see, we've got this 3a to the third power And then on the a squared, we have 6a squared minus plus negative, oh no, no other a squares. This is the only a squared. So we've got plus 6a squared. Let's see, what else do we have? Negative 5 plus negative 5a. That's negative 10a. But then we also have a plus 1a. So that's going to be negative 9a. And it's unusual to have this, a minus 5a. Usually it would just say minus 4a, but that's the way they wrote it. Okay, number 19, we have 3x squared subtracted from 1x squared. So that's negative 2x squared. And then we have 17x minus 5x, which is 12x. And number 20, we start with the r terms. 5r minus 9r is negative 4r. And then negative 2s minus 11s. We're subtracting a negative. So, right, it's a not, so we make it positive. So that would be negative 2 plus 11, which would be positive 9s. Number 21, we have to, again, be careful. We're subtracting a negative in this one as well. So we have 4c minus 4c. We're not subtracting a negative. We're eliminating 4c. It's 4c minus 4c. Okay? So the 4c's go. Okay, it equals 0. Goes away. Then we have negative 11 minus 11, which would be negative 22. And that's the answer. So number 22, so you really got to make sure you're good with your positives and negatives. Remember, we've got a subtraction in the middle and we've got a negative over here, so we need to be careful with that constant. So we'll start out with 3m squared minus 1m squared, so that's 2m squared. Then we have 7m minus 2m, so that's 5m. And then we have negative 1 plus 5, which would be positive 4. And number 23, let's see, we have negative 1, invisible 1 there, v squared minus 1v squared. So that would be negative 2v squared. We have 7v plus minus 8v, so that would be negative 1 or negative v. And then we have 14 minus 15, which would be negative 1. And number 24, let's do the x's first. We have 8x minus 5x would be 3x. Negative 3y minus 2y would be negative 5y. And then we have that plus 13 because we're subtracting a negative. So it would be plus 13. And number 25, we're asked to find the sum of 8p squared minus 2p plus 15 and 11 minus 2p squared minus 1. So 8p squared minus 2p squared is 6p squared. Negative 2p has nothing on the right side to combine it with, so it's just negative 2p. And then we have our 15 plus 11 minus 1, that would be 25. And that's the final answer for that. Now, we have a turnaround phrase. Subtract 2w squared minus 5w plus 10 from w to the third power plus 6w to the second power minus 2. So let's write that out correctly. W to the third power plus 6w to the second power minus 2, take away 2w to the second power minus 5w plus 10. So w to the third power minus 2w would be 1 minus 2, which would be just to make sure that I wrote this right. Subtract 2w to the second power. Oh, I don't have any other w thirds. I'm sorry. This is the only w third. Okay, w to the third. Now, 6w to the 2 power minus 2. That would be 4, w to the second power. And that's taken care of. And then we have negative 2 minus 10, which would be negative 12. And that's our final answer. So for homework, we just have one page of them, and I think you'll do pretty well with them. Go slow with the long ones. And let's go back to our exit ticket. So polynomials, how are they classified? Polynomials are classified by degree and terms, the number of terms. So good job. A lot of you did very well on Unit 6. I'm looking forward to seeing what you do with Unit 7. Remember, with practice, you'll be great. Thank you for paying attention and for being great students.